I'll make a case for special creation, and Fro makes some fair points. He has some fair points. We find similarities in anatomy, morphology, genetics, and physiology across the biological world. The evolutionary model would explain those similarities as being the result of common ancestry, universal common ancestry, ultimately. And creationists would argue that those similarities are the result of common design. The Bible says that we as man are created in the image of God. Therefore, we should be able to get a sense for how God created based on the way we as humans and human engineers design things. It turns out that we design in homologous patterns. We design in nested hierarchical patterns. A sedan has a lot more in common with a hatchback than either do with a boat and an airplane. So you see a natural nested hierarchy within designed modes of transportation. So overall, the similarities that we see in the biological world, they are agnostic. They're what's called non-differentiating lines of evidence. What we need is a way to differentiate between the models. We need discriminatory data. And so that's where I argue that the differences make all the difference. And so both models, creation and evolution, can explain the similarities. One model is explaining it through common ancestry or common descent. The other model is explaining it through common design. Human engineers design in homologous patterns. Why shouldn't God? Makes sense. Okay, let's go. Let's move on to an argument that can actually help us answer or resolve this question. And so here's my argument, and I'd be curious to see how Fro responds. There's one of many discriminatory data points that precludes common descent. What I mean by precludes is it makes the common descent model impossible because it simply can't account for this data. And so this specific data point comes in the Y chromosome. And so the special creation model would suggest that God created Adam and Eve, humans, separate from any other form of life. That includes your great apes, like your chimpanzee, your bonobo, your orangutan, your gorilla. Okay. The common descent model argues that humans and chimpanzees go back to a common ancestor about 6 million years ago. Okay, let's test that. Because theistic evolutionism is dead in the water if the science simply isn't there. What's the point of reinterpreting or just interpreting in general the scriptures in a way that is supposed to be consistent with a science that is simply pseudoscience? Okay, so here's the argument. If you look on the screen here, if my screen is shared, let me go. Okay, so these are Y chromosomes. Y chromosomes of the great apes comes from the conventional literature. They have humans as great apes because the evolutionary model sees humans as human great apes and then chimpanzees as non-human great apes. So these are the Y chromosomes. It's uniparentally inherited DNA, meaning we get it from our fathers. I got my Y chromosome from my dad. It's passed down paternally. It's non-recombining. That means there's no genetic shuffling each generation because it's not biparentally inherited. So there's not two chromosomes that are lining up, okay? So it's less messy. It's passed down largely unchanged. And so it should be relatively more stable or easier to determine ancestry than if it was autosomal DNA where you have recombination every single generation, okay? So what do we find? Well, we find exactly what we would expect if the special creation model were true. So here's the human Y chromosome. Here's the chimpanzee Y. Let's stick with the chimpanzee since the chimpanzees are supposed closest cousin.
Bonobos, actually.
No, chimpanzees, they would say, is our closest cousin. But they would argue that chimpanzees and bonobos are related and go back to their own common ancestor. Chimpanzees, bonobos, right in here. So no, they would argue that chimpanzees are closest cousin. So the human Y chromosome, when you consider overall size differences, architecture, here's heterochromatin, euchromatin, it's all color coded. It's very nice and neat here. And so when you consider overall gene content, size differences, right off the bat, you can see the human Y and the chimpanzee Y are completely different. The chimpanzee Y is half the size of the human Y. Gene content's totally different. The heterochromatin is almost completely missing in the chimpanzee. So you can read the associated papers themselves and notice what they say. Their Y chromosomes differ enormously in size and gene content. Puzzlingly, in terms of shared genes and overall architecture, the human Y is more similar to the gorilla Y than to the chimpanzee Y. Well, there's a break in your so-called nested hierarchy. And they admit that the human Y and the chimpanzee Y are only half the size. Notice this. The chimpanzee Y is only half the size of the human Y. So you can see that all here in this visual. Okay. So the human Y and chimpanzee Y, they're only about 35 to 45 to 40% the same. That's nothing. They're nothing alike. So when I say the differences make all the difference, we both would explain the similarities. You due to common descent, me due to common design. But when we look at the differences, the evolutionary model,
not people living on this.
The evolutionary model. I'm not done making the argument. I want to see you guys respond. The evolutionary model can't account. The evolutionary model can't account for such significant differences.
Can you stop interrupting, please?
The evolutionary model can't account for these significant differences. So this, from the special creation starting point, makes sense, because from the separate ancestry model, we would say that humans are their own created kind. Chimpanzees and bonobos are their own created kind. Their Y chromosomes are very similar. Gorillas are their own created kind. They go back to their own common ancestor. And then your orangutan, same thing. Your different orangutan species, they go back to their own created kind. This fits the created kind model. Now, how does the evolutionary model? Here's the question. If humans and chimpanzees are related, and we should even entertain theistic evolutionism, how do you account for these massive differences in just 6 million years since the split? And I want a sophisticated mathematical model explaining this. I don't want rescue devices. I don't want just so stories, because sure, anybody can have a story. Well, but that doesn't make it science. Go ahead.
The issue about that is, Donny, unfortunately, I'm unable to do that, because what you're arguing here, which is scientific literature, is kind of outside of my area of expertise. Okay, you probably know more science than I do, because I'm studying philosophy.
Yeah, but you said, but you said earlier that the evolutionary model has better explanatory power. I brought this up. Hey, Fro, correct me if I'm wrong. I don't want to be aggressive. I brought this up to you going back about a year and a half, roughly. Right. So in a year and a half, how come you haven't looked for an answer? If you're so devoted to theistic evolution, I'll tell you, I've debated PhD scientists on this exact question. And I have an article right here, okay, 2020, and they're still at the hypothesis stage. They haven't actually evaluated their hypotheses, their rescue devices in subsequent studies. And so I know for a fact there's no answer, not even from your best evolutionary biologists. And so if the evolutionary community can't explain this data that the separate ancestry model can, why are we saying that it is science that humans and chimpanzees are related? Answer that.
Right. Is that Fro the Catholic?
It is. Hello.
And it's good to see it, Fro, by the way.
Yep. And again, for that, it's not, I don't quite have the answer either. I'm not going to claim knowledge where I don't have it, but particularly evolution more compelling, not just because of what it can't answer, but
okay, but stick with this. How is it more compelling? Everybody in the audience can see the human Y chromosome and the chimpanzee Y chromosome. How is it more compelling that humans and chimpanzees are related rather than humans being specially created, separate from chimpanzees, in light of their Y chromosomes that are non-recombining? They should be relatively more stable. The mutation rate is about 1 to 3 per generation, and every single Y chromosome on the planet, male Y chromosome, can be traced back to a single common ancestor. You're making general statements, Fro, like, well, the evidence for evolution is compelling. We're looking at a data point right here. It's staring us in the face.
Right.
And this data point is telling us that no, it is not more compelling, because the chimpanzee Y chromosome is far too different for chimpanzees and humans to be related. Let's do this. I understand you don't have an answer, but let's use critical thinking skills then. Let's assume evolution is true, common descent is true. How can we go about answering this question of the Y chromosome? At the top of your head, what could be a possible explanation for how these Y chromosomes can change so radically in just 6 million years, Fro? Go ahead, my good man.
Well, because I don't really think they're changing all that radically, because again, you have to understand, a generation from great apes can occur within 10 years of life. So like for instance, we found a fossil of Homo erectus, which we would all agree is an ape.
Homo erectus is human.
I don't agree.
No, hold on. We found, again, I never said they were. I said we found some evidence they might have been, but it's inconclusive.
No, you said we'd all agree.
I'm not going to do it for sake of time. I have hundreds of PowerPoints, but there's one article that Erectus was a sailor because they built boats, they navigated. Purposeful navigation speaks to intelligence. Okay?
Well, actually, I'm sorry, this is the first time I'm hearing about this. Where'd you hear that from?
If you'd like me to pull up the article, I can certainly do so.
No, actually, I don't want to take away from your from the PowerPoint you got up. So just tell me the article. I'll look it up.
Well, I got to pull it up since I don't have every single title to these articles memorized. But the evidence for Erectus being human is overwhelming. The evidence for Neanderthals being human is equally overwhelming. Absolutely. That they were a sophisticated people group. But as I find this article, Fro, the human Y chromosomes being 35% the same, that's a lot of difference. And even in the technical papers themselves, they speak words such as surprisingly. They talk about unexpectedly.
Right. And so to answer that, there was I brought up Homo erectus, and there was a reason, because they found a Homo erectus fossil, and they wanted to find out how old it was. And one of the ways they configured that was by looking at its teeth enamel, because typically our teeth are a lot like our skin, but somewhat of a more consistent data marker to determine age. And the reason being is because the older you get, the more layers of enamel you're gonna have, especially when you eat things. The enamel wears away and new growths have to be made. And so they estimated that when this specimen of Homo erectus died, it was 10 years old. It stood about 6'3" tall. Okay. And so Homo erectus, since we agree they were human, matured at a much more rapid pace than we do today. And so what ultimately this amount of change in 6 million years would be unsurprising if we understand that these individuals could be sexually mature by that age, as opposed to us, where it typically takes us between 12 to 16 years. Okay. But again, you'd be hard pressed to find a 12-year-old that's 6'3", right? And so the thing about it is, these kinds of changes can be explained.
How is that going to change the Y chromosome? Half the size, gene content totally different, architecture completely different, heterochromatin basically missing in the chimpanzee line. And so if you look at the visual, you have humans and chimpanzees apparently going back 6 million years. So they split. Human lineage goes one way, chimpanzee lineage goes the other, eventually breaks up into bonobos. So within that time frame, all of the heterochromatin has to be lost. Half of the chromosome has to be lost. Entire chromosome rearrangement needs to occur. Okay. Yet evolution is more the most parsimonious answer would actually be that humans and chimpanzees aren't really. I want to show this. Notice this right from the conventional literature. This is the famous paper about the human and chimpanzee Y chromosomes. Notice this. Surprisingly, so it's not like this was predicted. The gold standard of science is making testable and falsifiable predictions, right? Well, this wasn't predicted. They admit, surprisingly, however, more than 30% of chimpanzee MSY, so a certain part of that Y chromosome sequence, has no homologous alignable counterpart. That means it won't even align to the human Y chromosome. I mean, this is exactly what we would expect if humans were created separate from chimpanzees. Right. And this was back in 2010. 2010, Fro. And look at this. 2020, my good man. They still admit that these hypotheses need to be evaluated in subsequent studies. That's 10 years plus another 4. That's 14 years. They still don't have a good answer. What do you think?
Well, how about the fact, Donnie, on that paper I sent you about the human Y chromosome being fully sequenced, and that wasn't up until 2023, adding 41 protein pairs and millions of other base pairs that they didn't even know about. How much more does that take away from the comparison of the chimp Y chromosome and a human Y chromosome?
Right. Well, right here, we're looking at head-to-head predictions, right, Fro? You would argue, according to theistic evolution and universal common descent, humans and chimpanzees are related. I would argue humans and chimpanzees aren't related. Adam and Eve were created separate from any other form of life. And so rather than arguing, are humans related to strawberries and banana plants, let's stay as close to home as possible. Let's pick the chimpanzee, which the evolutionary community argues is closely related, our closest cousin, today. And so if we can refute and show preclusionary data that suggests humans and chimps aren't related, then obviously, as a result, humans and strawberries can't be related. And here's the thing, though. Human Y chromosomes have extremely low variation, Fro. Me, you, praise, no matter what Y chromosomes you look at, very low genetic diversity. But yet the mutation rate is fast. A lot of mutations are accumulating every generation. So why don't we find extremely divergent Y chromosomes globally? And why is there such uniformity in human Y chromosomes? Then you bring in the chimpanzee Y chromosome, and they're completely different, matching creationist expectations. But a surprise to evolutionary scientists.
Well, I'm not sure why it would be a surprise to them, because this is also one of the things that evolution predicts as well. Because
right here, surprisingly.
Well, I know they said that, Donnie. I'm not denying that. But like evolution itself, you wouldn't necessarily find that surprising. The reason being is because part of the, how I'll put it, the very mode of evolution is going to be the alteration of genes. Okay.
Not an unrealistic amount of alteration in the genes.
Well,
that's a huge amount.
Well, again, and again, that depends. Is it really unrealistic? It might be, how I'll put it, it might be faster than anticipated. It doesn't mean it's unrealistic.
Okay, Fro, look at this. But again, this is not science. This is just, well, maybe this, maybe that, story time, imagination. Notice this, puzzle. This is their own words. Puzzlingly, this is a puzzle to them in terms of shared genes and overall architecture. The human Y is more similar to the gorilla Y. That's a break in the nested hierarchy. That means your human Y chromosome and gorilla Y chromosome, they're more alike than either are to the chimpanzee Y chromosome. And notice what they say here. This is 2020, by the way. This is 10 years after the original paper. They're still puzzled. They're puzzled for 14 years. Notice this. It says, the percentage of gene families shared by these two chromosomes that split, apparently 6 million years ago, pay close attention, is similar to that shared by human and what? Chicken autosomes that split more than 310 million years ago. That's how different. That's a lot of difference. Now, we can pretend to be an evolutionist and come up with rescue devices that are not tested, but that's pseudoscience. That doesn't belong in a science textbook. It's not empirical.
Mm-hmm.
Or we can go with the most parsimonious explanation that says, hey, the reason why the Y chromosomes are so immensely different is because humans and chimpanzees simply aren't related. Let me ask you this, Fro.
Mm-hmm.
Is it possible that the reason they're so different, is it possible that the reason is because they're not related?
I guess that's a good question. I would say, that is possible, but like, I think plausibility might be more what we want to argue here for. Let me ask you another question. So right now, you're right. In about 10 years, they might not have an answer to this question. What if we make it to 2030 and they finally decode why that is? Does it make young Earth creationism still the most parsimonious explanation now? If they have a valid evolutionary reason as to why these mutations exist?
It's an excellent question, and I'm glad you asked it. What that would mean is the Y chromosome argument is no longer a discriminatory line of evidence. It becomes agnostic. It's different according to the biblical creationists because they're not related. To the evolutionists, it's different because, and then whatever the explanation is that's tested in 10 years. Now it's agnostic. Now we got to go look to another way, like mutation accumulation or molecular clocks or linkage blocks. There's a number I could go to. So what you would have is just another agnostic line of evidence where both models can explain it. But currently, the evolutionary model can't explain it.
Yep. And for this, again, without being particularly knowledgeable in this particular data point, Donny, I'm willing to give you the win on this data point. Okay, because if it currently isn't explainable by modern science, then it's just not explainable, right? So the issue about it is, though, and I kept what you just brought up. Even if we can concede this data point to young Earth creationism, it doesn't mean young Earth creationism is capable of explaining other data points that we have equal access to that most definitely would be in the favor in the arena of evolution.
Well, it would have, and that's a good point. It would have to be, and remember, we're talking about ancestry here. We're talking about theistic evolution because there's old Earth creationists that are intelligent design advocates like Casey Luskin, Stephen Meyer. There's many who would argue for separate ancestry, but believe in an old Earth. So when it comes to the ancestry question, the age of the Earth is not necessarily in question. It can be because the level of variation, I would argue, in terms of mutations and DNA differences only give us a few thousand years. But we can go there after we settle the issue of whether or not humans and chimps are related. So yeah, I would love to see in genetics, something related to ancestry, a line of evidence that only the evolutionary model can explain, that the separate ancestry model can't.
Yeah.
Because that's what we need, is a discriminatory line of evidence. So Fro, is there one that would provide us with that kind of evidence?
That's a good question. The best argument I can make, and again, my opinion is informed here because there's several reasons why I think evolution is a plausible model. Now, again, not necessarily the correct one, but more plausible than creationism. And one of the reasons is because of the predictions that evolution has made. Like, say, for instance, evolution assumes universal common ancestry, and I think this was brought up to you, Donny. One of the a lot of biologists question, well, if we came from a common ancestor, what we would expect to find is basically creatures that are somewhat oceanic and yet also amphibious too, that are equal, that have equal parts aquatic and actually parts that you would expect to find on land. And again, that was actually predicted. Like where in the fossil record would this occur, and where would we dig for it to find it? And ultimately, that's exactly what they found. They found I forget what it wasn't coelacanth, something else. Hold on. Tiktaalik, you got it. And so essentially they predicted Tiktaalik, not even knowing what the creature was, but just by assuming universal common ancestry, where about in the fossil record it would live and where to dig for it, should it have lived, and they found it. I think the very fact they were able to make a hypothesis, predict it, and then prove that prediction means that even if evolution is not entirely true, at best you could say it's flawed, okay? You can't say it's just absolute pseudoscience. There's clearly something powerful going on in the theory itself that doesn't really disqualify the belief writ whole, as much as there's definitely room for improvement, right? And so in a similar way, even if I were to
okay, well, let's stick with that, Fro.
Yeah,
let's stick with Tiktaalik.
Let me kind of put it to you this way.
Predictions.
Even if I were to even if I were to concede this part of the argument to you, I think given that and other things we know about evolution, it doesn't conclude that we should outright deny evolution. Then, does that make sense?
Well, I would argue that it's in our genetics. That's the best way to answer this question of ancestry, because it's a direct way to answer the question of ancestry. A bone, a fossil, geography, these things are not inherited in sperm and egg. And there's a lot of reconstruction, historical reconstruction when it comes to the fossil record. You know, there's a famous quote that says fossils are fickle and they can tell any story that you want. The genetic data, though, that's empirical, that's real time, that's observable, that's direct.
Right.
And so our historical reconstructions based on the fossil record should be consistent. They should not contradict the genetic data. And so if we have genetic data like the Y chromosome that tells us that humans and chimps aren't related, meaning then that humans and fish definitely aren't related, then we can't be interpreting or reconstructing fossil data that says humans and fish are related, because then you're just imposing your evolutionary philosophy on the fossil data where it doesn't actually belong. But the second point is this confirmed prediction? Are these lines of evidence agnostic, where both models can explain it? Or do they provide us with discriminatory evidence? And I would argue that Tiktaalik, which is who you're talking about, is largely agnostic. Tiktaalik, how precise, what was the prediction that you're describing?
Very precise in that they were able to basically locate the geographical area where this fossil would be after millions of years, and the very fact of the sort of environment this creature would have lived in, basically just reconstructing that with the movement of tectonic plates and the assumption of universal common ancestry. And they found a species of exactly what they were looking for. And because they had no prior knowledge of Tiktaalik. They just realized if something like Tiktaalik were to exist, this is how it would have existed, and went to a fossil bed that would fulfill that criteria the best.
And so Tiktaalik, you're saying, here's Tiktaalik on the screen. Tiktaalik blends the features of fish and tetrapods.
Yes.
So
like a salamander.
Okay, so I've got somewhere where I'm going with this. Don't worry. The famous fishapod. So you guys make this prediction, you find it. It's this creature that blends the features of both fish and tetrapods. So does that mean, as a fulfilled prediction, we only then find tetrapods after Tiktaalik and not before?
I don't know if tetrapods were before Tiktaalik. You might know more about that, and if they did exist, then I'll concede.
Well, is Tiktaalik the transition from fish to tetrapod?
That's typically how it's advertised.
Okay, so therefore we shouldn't have true tetrapods before Tiktaalik then, if Tiktaalik is a representative or an example of the transitional form, evolving into tetrapods.
If tetrapods did exist before Tiktaalik, they would most certainly be oceanic.
Well, here's the thing. They made the prediction. They discovered Tiktaalik, but then years later, they discovered tetrapod foot tracks, true tetrapod foot tracks in rock layers in Poland that predate Tiktaalik by somewhere between 20 and 40 million years, according to the conventional timeline. And so I would argue that it's a failed, or at best for the evolutionists, an imprecise prediction.
Well, again, that would kind of depend on whether or not where this fossil was found, because again, if these foot tracks were found in essentially oceanic layers, what we can say is that kind of oceanic tetrapods existed 20 million years before Tiktaalik, and probably made its footprints on low-lying coastal ground. Okay, but ultimately, like for instance, if these foot tracks are found in a rock layer that was not caused by the ocean, you actually would validate your point, because it would be rather strange for us to find tetrapods in a region of forest 20 million years before Tiktaalik. But if we were to find this, say, I don't know, in a riverbed 20 million years before Tiktaalik, that actually doesn't contradict the theory at all.
Well, the point is we find true tetrapods, and as we're discussing this, maybe someone can do a research and see what kind of environment they were found in. I know they were found in Poland. I know they are true tetrapods. They are foot tracks, undeniable, and they predate Tiktaalik by 20 to 40 million years. And again, they were shocked. They were surprised. Oh, looks like we're going to have to rewrite evolutionary history. But the bigger point is the fact that, okay, as you can see here on the slide, we have some interesting mosaics. Archaeopteryx, Tiktaalik. We could talk about the mammal-like reptiles, like the therapsids or the synapsids. Okay, interesting creatures. I would argue, if evolution is true, we shouldn't be sitting here arguing all day about one or two interesting cases like Tiktaalik, like Archaeopteryx, like these mammal-like reptiles. There should be just millions of these examples all throughout the fossil record, since all of these different types within your biological kingdoms, like kingdom, phylum, class, order, family, genus, species, everything needs to be evolving into a new group essentially over millions of years. So we should just find an abundance of these transitional forms. We do find a few interesting mosaics, but I argue that this is agnostic largely, in the same way that homology and nested hierarchies are, because again, my hypothesis is we should be able to get a sense for how God designed the biological world based on the way we design things. And it turns out that we design interesting intermediates, interesting mosaics. A couple examples: the crossover SUV. Is a crossover SUV an SUV, or is it a van? No, it's something in between. But the thing is, it's not that the SUV is evolving into the van. It's that the van is a good design. The SUV is a good design. They both meet a general need. And so is your crossover. Look at this one in 1961, Amphicar. I mean, this guy's just cruising along in some car that's able to act as a boat. Somebody thought it'd be interesting to design.
Yeah, but that is a sweet car.
Yeah, imagine rolling up to work in that thing. And so the point is, yeah, God's created some interesting mosaics for functional purposes, in the same way that man has designed some interesting intermediate or mosaic forms. The best one that I like is the military amphibious assault vehicle. Why I like this one, Fro, is because it's very similar to Tiktaalik. As a tank is not good in the water, a boat's not good on land. And so what does the military design and invent? A military amphibious assault vehicle. Now, this vehicle is not all that good in just the water. It's not all that good just on land. It's perfect for the intermediate environment between sea and land. And again, this is for design purposes. We see the same thing in the biological world. And so the evolutionist looks to that data and argues that it supports their position. It's what they would expect. The creationists, the same thing. It fits the design hypothesis. And so now we have another agnostic line of evidence, as in it's not really doing anything to further the debate, since both models can generally account for it. Does that make sense, Fro? And feel free to speak to that.
Yeah, no, that would, yeah, that does make sense, actually. I can't find any particular flaw with that logic yet.
That's why I'm not even going to sit here and say, hey, Tiktaalik, Archaeopteryx, your therapsids, right? There's an interesting group of creatures that you find in the fossil record called your mammal-like reptiles, where they literally blend the features of reptiles and mammals. Well, the evolutionary model says that creatures evolved from fish to amphibians to reptiles to mammals. Reptiles to mammals, you seem to have this in-between group, your therapsids. Okay, fine, interesting, right? I'm not going to say that that's not a line of evidence for evolution, but the thing is, can the creation model also explain it? And the answer is yes. And so we need to look to lines of evidence that discriminate or can help differentiate the models. And that's where I would look to the genetic data, the Y chromosome being one of them, because now we have a line of evidence that only one model can account for and the other can't. And so that would be preclusionary evidence. And I think that's where the debate needs to take place. Right. Rest. Yeah. That's a good word for it. Yeah.
Okay. Well, thank you for that, Donny. That was very insightful. Thank you.